G'day guys, we've got some algebra questions here today which we have to solve using logarithms. So let's read the question. We've got solve each of the following equations giving exact answers involving logarithms. Alright, so we've got 3 to the 2x plus 1 equals 2 to the 3x minus 1. Now when you have the unknown that you're looking for in the power, that's a pretty good giveaway that you're probably going to have to use some sort of logarithmic based solving method. So in the second one, we've got 5x plus 4 times 5x plus 1 equals 63. Okay, so let's start with the top one. Now, when some people use log to the base 10, today I'm going to use just, so for this part here, it says involving logarithms. I'm going to use the natural logarithm, so log to the base e, because it's just an easier one to use. So that's like the natural log ln. Okay, so we'll start with this one. Now, when you've got nice, simple looking equations like this, the easiest thing to do to start with is to take advantage of this law here, where you have ln of a to the x is equal to x times the ln of a. So you can get the power and you can move it to be the coefficient. So in these ones, the powers are 2x plus 1 and 3x minus 1. So we're going to say that 2x plus 1 ln of 3 is equal to 3x minus 1 times the ln of 2. Cool. So once we've done that, we can multiply out the brackets and we're left with 2x ln 3 plus 1 times ln 3, so it's going to be ln 3 equals 3x ln 2 minus ln 2. Cool. So what I'm going to do is I'm going to take the ln 2 over to this side, over to the left, and I'm going to take the 2x ln 3 over to this side. So basically what I'm going to do is I'm going to minus 2x ln 3 from both sides. And I'm also going to plus ln of 2 to both sides. Cool. So basically what that does is, well, obviously we do it to move the things. So these will cancel. And then what we have remaining is we have ln of 3 plus ln of 2 equals 3x ln 2 subtract 2x ln 3. Now we can use a log law here for these part of the equation. We're going to have ln of AB is equal to ln of A plus ln of B. So we're going to go backwards here. We're going to say if we've got two things added together, we're going to be able to multiply them inside the same thing. So this one here is going to be now ln of 6. Now, we're going to factorize this side here. Now, this is quite a common thing. If we've got x's in both expressions, but we have like different logarithms and so we can't add or subtract them, what we're going to do is we're just going to factorize by x. So we have 3 ln 2 minus 2 ln 3. Now, what we can also do, so then we're going to, with this side of the equation, we're going to take this log law and we're going to go backwards. So we have x ln a, but we're going to take it back to ln of a to the x. So this is going to be x outside of ln of 2 cubed minus ln of 3 squared, and that's equal to ln of 6. Now the next log law we've got is we have ln of a divided by b is equal to ln of a minus ln of b. So we're going to use that log law on this. So we know that 2 cubed is 8, and we know that 3 squared is 9. So this is going to be ln of 8 divided by 9. So let's just move ourselves over. Cool. So first of all, we have ln of 6 equals x times the ln of 8 over 9. And then what we're going to do is we're just going to divide both sides by ln of 8 over 9. So x then will be equal to ln of 6 divided by ln of 8 over 9. And that's all she wrote for the first one. So basically what we've done here is we've separated out all of the different components. We've then collected like terms on both sides, whether it be the x or the numbers. We've then factorized by x. We've then done the reverse of the log laws, and then we've found our answer. So we'll get on to B next. Okay, so on to part B. So we've been given 5x plus 4 times 5 to the power of x plus 1 equals 63. Okay, so what we're going to do is we're going to use an index law here where we have a to the power of n plus m is equal to a to the n times a to the m. So we're going to use that to expand this 5 to the power of x plus 1 term. So we're going to have 5 to the power of x plus 4 times 5 to the power of x times 5 to the power of 1 equals 63. We're then going to multiply the 4 into the bracket. So we're going to have 5 to the power of x is equal to 20 times 5 to the power of x equals 63. Now, in this question, I'm pretty sure that logs aren't going to come in until right at the end. Why have I got an equal sign there? That is supposed to be a plus. Now, we're going to factorize by 5 to the power of x on the left. Cool, now this is equal to 21. Now we can divide both sides by 21, and we're left with 5 to the power of x equals 63 divided by 21 is 3. Cool, so now we can take the logs, or the natural logarithm of both sides. So we're going to have ln of 5 to the power of x equals ln of 3. And then we're going to use this log law here, which will give us x ln 5 equals ln 3. Then we can just literally divide both sides by ln 5, and we have x is equal to ln 3 over ln 5. And that's all she wrote for this one. So I guess these are the two A and B were two completely different problems. Like the first one, we needed to use logarithms right from the word go because the equation couldn't be we couldn't do anything to it until we'd gotten rid of those. We'd gotten the x down from the power. Sorry. In the second one, though, we had a little bit of leeway to be able to use algebra to just simplify it down before eventually we then had to use log laws. Now, these sort of problems are going to require a little bit of time and practice to try and so you get a feel of, you know, when you're going to need to use algebra, when you're going to need to use logs to be able to solve it. Most of these complicated algebra styles, like solve for x and give your answers exact values, are going to involve some form of logs. So I'd get used to them. You're going to need them later on. But I hope this video helped in your sort of quest to get better at logarithms. If it did, subscribe to my channel. If you need any help with any other questions that you've got, just send me a message. Like, subscribe, you know the whole deal. I'll see you guys next time. Until then, have a good one.